Okay, maybe that intro wasn't the best way to describe this project. Let me clarify. I, like everyone else, hate getting up in the middle of the night. Whether it's to drink water, go to the bathroom, or turn on my air purifier because I want the white noise. So today, I'm going to come up with a creative solution to fix that problem. This is our victim. Our mission today? Make a remote control so that I can activate it without getting out of bed. But wait, I hear you ask, how are you going to make a box remote control? Well, by using this assortment of parts that I've gathered, coupled with this very authentic Arduino Uno. As you can see, I have a lot of parts here, half of which I know how to use, and the other half, well, we don't talk about the other half. But hey, lucky for me, the parts I do need, I know how to use. Provided I have the library that goes with them, because I don't have time to code 3 pages worth of scripts for these individual parts. So anyway, let's get down to business. Oh, that reminds me, I also have a laptop, which is very useful when you're programming microcontrollers. Alright, game plan. Step 1, build a frame for this servo using popsicle sticks and hot glue. Step 2, take some measurements and 3D print a frame that will attach the servo to that little knob right there. Step 3, I'm going to wire the Arduino up and make sure everything is all set up for step 4, which will be programming the Arduino and finalizing the project. Let's get to it. Alright, let the games commence. First things first, I started by placing popsicle sticks without any glue down to figure out how I wanted to attach this thing. Then I started with a basic frame. You may notice at this point that I'm not using any hot glue, and that's because my glue gun decided to quit right then and there. So I grabbed some 5-minute epoxy and made do. Also note that I removed all the excruciatingly long pauses while waiting for said epoxy to dry. Now I had a base for the frame, but I needed something attached to it so that I can actually mount the servo. So I cut up a few pieces of popsicle sticks and stacked them up to raise the servo up to the knob on the filter. Add some supports and a bit of glasses-free machine sanding, and you get a pretty convincing support for the servo. And we're ready to move on to the next step. At this point, we have a nice frame and a servo attached to the frame. Now, I have taken the measurements, and I will begin to 3D model the little piece I have. So the piece is the knob that I took off of the air purifier, and I will 3D model it. So, as is custom in Blender, you delete the first cube, and now we may commence. So, the first measurement I took was of the holes I decided I wanted to use on the servo. 2.1 centimeters apart. Both holes are 2.1 centimeters apart. And that means that I need 2 holes at either extremity of this. Here it says meters, but that's because if I tried modeling it in centimeters, Blender would misbehave. So I'll model it in meters, and I know that that's, just 100 times bigger than I need it to be. Now, let us add a new object. This time we'll add a cylinder. Let's switch to face select and extrude those faces ourselves. So we want it pretty thick since 3D printing isn't as good as injection molding. And now we have a circle, but unfortunately that's not what we need, because if we just had a circle it would turn around the knob and not do anything. So what I need to do is make this circle here flat. I'm sure there's plenty of really smart ways to do this. Unfortunately, I don't know any of them. So I'm going to do this my way, which is gonna suck, but it's gonna work. There you go, that's about it. So I'm actually going to undo. I'm going to leave it like that, just to be sure that the knob fits, because the knob won't turn anyway. It just won't be a perfect fit. Now there's one more thing I need to do, and that is not be a perfectionist when it comes to the size of this, because right now I made that diameter the exact size it needs to be. So I'm actually going to make it just a tad bit bigger, because 3D printers are not perfect machines, and so I would like for this to work well. Oh, there we go. So, hey, you're supposed to be applying to the other side. Oh, Boolean comes before that. I just have to put the Boolean on top. Okay, that didn't break anything. Well, this? No, wow, that's working gloriously. We have a problem with this piece here, and that is it's not properly attached. Let me show you. It lines up perfectly with that bottom piece. That's something that might ruin me. So let's fix it. So I'm gonna just extrude that roughly well, that's way more than half. Just stick it inside the shape, because that way I know that when I prep it for 3D printing, it will fit gloriously. Awesome. Now one last little thing. I'm gonna grab this shape right here, which is being surpassed by that, and I don't like that at all. Set that up. Bring back the main mesh. This is what our final piece looks like. And if I did everything correctly, this should work fine. So let's send it to the 3D printing software. Stick it in Dremel. Take this lovely file here. Plop it down. 31.8. Now this here is the object we're going to be printing. We'll try our best. Something went wrong during slicing. Why is something going wrong during slicing? What's wrong with you? Can I just do the defaults? What? What's going on? I might try this one. I've never used this one. I guess we can try it. Can I use degrees or something? That's not even close to what I want. Enable printing a brim or raft. Really? Hey, that worked. That's G-code. That's literally exactly what I need to be. Wow, that's freaking awesome. Now, you guys get to see the super awesome 3D printing magic. Talk to you guys shortly. Alright, day 2 of the project. We now have our popsicle stick frame that will hold our servo in place right in front of the controls for the air filter. And we also have the little 3D piece that we made last night that has 2 little holes to attach to the head of the servo. Unfortunately, the piece printed out a little too big and will need to be sanded in order to fit onto the controls of the air filter itself. So that's what we're going to be doing, and we'll see how that goes. Alright, so I'm going to put you right here. There's not much to say here. It's a lot of sanding, then testing over and over again until eventually I get it to fit nicely. Also, I know I should be wearing glasses, but I keep my eyes away from where the shrapnel could go flying, and I'm very lazy. So remember, I'm setting a negative example, and you shouldn't use any equipment like this without the proper protection. Alright, so now the piece is sanded, it fits nicely and turns nicely, which is what's important.
And now we're going to start wiring our boards to all the parts we're going to use. So I have an Adafruit Feather here and the Arduino Uno. I'm not sure which one I'm going to use. I'm going to figure that out as I go along. But we're going to start with a nice breadboard, probably this one right here. And we're going to wire all the parts we want onto the breadboard and set it up for programming, which will be the next step.
Alright, now for the wiring. I started by grabbing all the parts I wanted and placing them on the breadboard. The list is short, but regardless, I wanted to show which mode the filter was in by using a display. I also wanted to use an 8-bit serial parallel IC microcontroller to reduce the amount of pins I would need to sacrifice for the said display. The rest is obvious. I needed an infrared receiver, and of course, the servo, which we've been working towards for this whole project. I decided to use an Arduino Uno as opposed to the Adafruit Feather because the Feather is super convenient and I don't want to waste it on this project. The Arduino is more basic and suits the needs for this project just fine. I mounted everything onto an 830 breadboard and started wiring all of the components together. I also didn't want to bother using all 8 of the pins that the serial parallel microcontroller has. So I only wired 6 of the 8 inputs my segment display has, since those were the only ones I was going to need for the project. I also made myself a little diagram on a piece of paper to keep track of which pin does what.
Alright, so now we have our little board here, still plugged into the computer because I was doing some testing. I decided to use the Arduino Uno on the back here. And I have the infrared sensor on the front. I have the little display here, which I'm going to have to tape the wire down so you can see it properly. This will display the current position of the knob and of the servo motor. Here we have a microcontroller that allows me to display this 7-segment display using only 3 data ports. And we have the little piece that I attached to the servo at the right angle, so 0 degrees means it's off, and so I can toggle between all of the options. I did find a little issue, and that issue is this part here, the part that twists the little internal shaft, is a little bit too loose, meaning that when you're turning it, it has some give. It's not a perfect connection.
Hi. I thought I would clarify this part in the voiceover since it's not too clear what I'm talking about. Basically, what I'm saying is that the piece I printed isn't perfect, and therefore needs to be rotated about 40 degrees before the rod inside the air purifier actually starts to turn, and can then register that the mode is being changed. The issue doesn't really affect you guys, but it does affect me when I'm going to be coding, so we'll tackle that in the next step. Alright, back to the video.
So now I'm going to go attach this to my little wooden structure and see if this thing works properly. I'll be right back. So now the servo is attached to the frame and the little knob is properly attached to the servo, and thus if I come here and I adjust my settings, I can have the servo set the air purifier to 0. And I can do it vice versa, and I'm going to do some testing to figure out exactly which numbers the servo needs to be at to trigger the different levels, because so far I know 0 is off and 190 degrees is full power. So I'll figure out the rest and we're going to start coding. So see you on the computer.
Welcome to the last step of our project, the coding, which turned out to be a little trickier than I was expecting. There were a lot of steps and quite a few bugs I had to work out, so let's quickly run through all the parts of my script. Let's start with the infrared sensor. I have 2 variables, a current position, and the previous position. When the sensor detects that a button, 0, 1, 2, or 3, on the remote is pressed, it changes the current position's value to the corresponding value. If this new value matches the previous one, the script waits for the next input and does nothing. If the values don't match, then the script uses a switch statement to determine what position the servo should be set to. Speaking of which, let's talk about the servo now. The servo has that issue with my 3D printed piece that I mentioned earlier. This was solved by adding 40 degrees to the final position of the servo when it needs to be turned clockwise. When turned counterclockwise, it removes those extra 40 degrees, and that actually worked really well. Finally, we have that 7-segment display that I mounted. It's one of those displays that are similar to a digital watch face. To make the numbers display the way I wanted to, I made an 8-bit array of the numbers I wanted to use, 0, 1, 2, and 3, 0 being off and thus displaying nothing. I used my little diagram that I drew to help me determine which bits should be on and which ones should be off. I had the script call out the position in the array corresponding to the number I wanted to display. This one gave me a little bit of trouble, but after about 30 minutes, I got it in the end. Finally, I tweaked the delays to make the whole thing run a little more smoothly, and fixed a few issues I was having with the overall script. Thank you guys for watching my first ever video up on this channel. It was a really long project. It was almost a whole week of work from start to finish. It was, however, a ton of fun, and I can't wait to start my next project. If you like the video, be sure to leave a like and comment if there's anything on your mind. I love to chat. So see you guys in the next video, and have a happy belated New Year's Day. I need to pee.